In this video, we're going to talk about scientific notation, and scientific notation is something you may or may not have seen in your science classes or previous math classes. I'm going to try and shed some light on some things that people typically have some trouble with, especially, do I move that decimal place left or do I move it right? So scientific notation, it's used in science specifically to represent very large numbers or very, very small numbers, such as we need to count how many cells are in our body. That's going to be a huge number. It's not going to be nice to write the whole thing out. Or I want to know the diameter of a cell or of an atom. That's going to be a very small number, difficult to express with a standard number, so we use this scientific notation. And scientific notation has the form a times 10 to the b, where a and b are numbers. And they have to be certain kinds of numbers to be considered a scientific notation value. So a must be a number that's between 1 and not 10. So anything up to but not including 10, a can be. If a is not a number between 1 and not 10, it's not what we call scientific notation. And b must be an integer. We've seen that we can have negative exponents, we can have fraction exponents, we can have decimal exponents. We need an integer value as this exponents. And if these two conditions are met, the number is what we call a number in scientific notation. So let's look at some powers of 10. 10 to the first is 10, 10 squared is 100, 10 to the third is 1,000, and so on and so on. We could keep listing these out. And if we took a number and multiplied by one of these things, we'll get a big number. 10 to the negative first, well, that's 1 over 10. 1 over 100 for 10 to the negative second. 10 to the negative third is 1 over 1,000. If we were to multiply something by these numbers, we would get a little number that is close to 0, so 0.000 something. So when it's 10 to a positive exponent, we're talking about big numbers. We're talking about multiplying by one of these things over here. When it's something times 10 to the negative, we're talking about a little number here. So positive exponent goes with something that's a whole bunch of digits in the decimal point. 10 to the negative exponent goes with something that's decimal point, then a bunch of zeros, and our two numbers at the end. So I don't like the idea of memorizing when it's positive, move left, when it's negative, move right, because I can never remember. I can remember way back when I was learning this, I could never keep it straight. So I like to think about, is it going to be a big number or is it going to be a little number? All right, so let's work with some conversion. This first problem, we're looking at the standard form, and we want to change it to scientific notation. To be in scientific notation, remember the first number has to be between 1 and not 10, so our decimal needs to go here. We're going to look at 2.734 times 10 to some power. And this is a big number, so the exponent on the 10 has to be positive, and what we're looking at is how far did this decimal place move. It was here after the last 0, it's moving 1, 2, 3, 4, 5, 6 places. The second one, we have a scientific notation number, and we're changing it into standard form. We see that it's 10 to the 5th, so we know that this is going to be a big number. It's a positive exponent. So we have negative 261, and we're going to move the decimal 5 places. We're going to move it 1, 2, 3, 4, 5. And what do we put in the empty spots? We put zeros. So there's our new decimal. This is negative 261,000 as the standard form number. Now let's look at the other side of things. Let's look at really, really small numbers. So I have 1.6 times 10 to the negative 4. That's a scientific notation number, and we want to turn it into standard form. We see 10 to the negative 4th. We're thinking this is going to be an itty-bitty number. It's going to be a decimal. So we're moving the decimal place that way 4 places. So we have 1, 6. We're moving it 1, 2, 3, 4, there's the new decimal, and we're filling in zeros to those empty spots. So it's 0.00016. For the next one, we need our decimal to be in here to be a scientific notation. 1.16, we need to be between 1 and not 10, times 10 to the, and it's going to be a negative exponent because this is a long decimal. It's an itty-bitty number. It's close to 0. Now we have to count how far we move it. We move it 1, 2, 3, 4, 5 places. And we make it negative because, remember, it is an itty-bitty decimal. And there we go. We've got some examples of converting both big numbers and small numbers from standard to scientific notation and vice versa.